Welcome back to B-Spice. In this session, we'll discuss about fiber optic cable, wherein we'll focus on the differences between single mode and multi-mode. Very, very important to understand this. Okay, when we prepare a spec, in a project requirement, we need to put forth very clearly what is your requirement. So based on that, contractor, the designer, they will procure and implement the project execution, right? So we need to be very very clear and precise. So that is the intent of this video. So of course the previous one we have covered the outline, what is single mode and what is multi mode, but this is about more of a differences. In detail we'll focus. Let's go into the detail. Okay, first core diameter. Okay, core diameter. As you can see here, the core diameter, of course, single mode, this is multi-mode and this is single mode. So single mode and multi-mode have a different physical core dimension. From the diagram, you can make out. In this, friends, if you see here, the multi-mode, as I explained earlier in that previous video, we have different modes, right? OM, optic multi-mode, 1, 2, 3, 4, 5, all these, right? Yes. So if you see here, the diameter is 125, 125, micrometer here. So when we talk about this, the color, that is, what you call the core actually, the core. So it is 62.5 micro for the OM1. And of course, for OM1, 2, 3, 4, and 5, it's 50 micro. So the point is, the core size of a mode fiber is small actually. A single mode is small. As you can see here, this is small, which is about 9 micrometer. Okay, right. So of course, other sizes also available, but this is the typical. Okay. So it has a lower attenuation, supporting higher bandwidth and long transmission distances. Just we need to be very, very mindful about this. So this is actually supported. It has a lower attenuation. So probably you may ask, what is attenuation? Yes. So attenuation is nothing but reduction in signal strength. Okay, as light travel through the fiber. Okay, attenuation is nothing but a reduction in signal strength as the light travel through fiber. One more terminology, bandwidth, we in fact covered earlier. Again, I repeat, it's amount of data transmitted. You should not confuse between bandwidth and attenuation. Okay, so coming back to the subject here again. So the core of single mode is small, okay, which is typically, 9 micrometer. Okay, this one, right? So it has a lower attenuation and supporting higher bandwidth and longer transmission distance, single mode. Okay. So the multi-mode, friends, it is much larger, of course, typically 62.5 micrometer or 50, right? Yes. So depending on the type of fiber, whether it's a OM1 or OM2, all these actually, yes, depending on the fiber type, the diameter varies, right? So OM1 is about 62.5 and OM2, 3, 4, 5 is about 50 micrometer. Okay. So although there is a clear difference in size, it is not easy to see these differences with the naked eye. That is a point. We need to be also watchful about it. This is because, they are all smaller than the width of the human hair actually. Just imagine a human hair smaller than the width of the. So usually we can check the printed code on the fiber optic cable to see printed code. So that is how we have to see. However, single mode and multi-mode fibers are 125 micrometer in diameter if they have a protective cladding. So meaning this one with a protective cladding, you can see this. This is your total what you call diameter 125. So this 62 is the core only. Okay. So this is in orange and this is yellow. Okay. That one just remember. So this is about the core diameter. Okay. Then we go into the wavelength. Okay. So wavelength, if we talk about wavelength, multi-mode fiber is usually suitable for 850 nanometer and 1300 nanometer. Okay. So this is about OM1. Okay. Wavelength. Okay. This is basically short wavelength. So because it has a larger fiber core, industry can offer the transceiver with low cost components like LEDs or what do you call VCSEL, that is vertical cavity surface emitting lasers. Okay, these are all the available in market actually. Okay, now let us not go into the aspects. Now we will focus on this. OM1, 850 nanometer, 1300 nanometer. Okay, and OM2, of course, same actually, not much difference and almost nothing much difference. Okay, but only in OM5 we have 953 nanometer options also there. Whereas in a single mode, you have a higher bandwidth. You see a wavelength basically, higher wavelength. So 1310, 1490 and 1550 nanometer. So you can make out actually, right? If you want a wavelength of this, then you have to go for this, right? Okay. So that's about the wavelength. I hope that is also clear. Then we go into the next one, bandwidth actually. Okay. So bandwidth, as I said, it is nothing but an amount of data transmitted. So there are two different types of fiber offer different bandwidth. Okay. You know, friends, because the single mode fiber optic cable support a single light source mode. Okay. It has a lower attenuation and less dispersion. Okay. So as a result, it can provide a nearly unlimited amount of bandwidth. So that means there is no limit actually. Okay. So this makes it a preferred choice for high speed interconnection over long distance in telecommunication. I just put not applicable because of this unlimited. Okay. Don't get it wrong. Don't get wrong, what do you call meaning. Okay. Right. So when we compare about this actually multi-mode, you see here minimum overfill model bandwidth length and minimum effective model bandwidth length. Okay. So for this OM1, it is 200 megahertz per kilometer at 850 nanometer. Okay. And yeah, 500 megahertz at 1300. Then for OM2, it differs 500 at 850, 500 at 1300, a little bit higher. And in OM3, we have even more higher bandwidth actually, 1500 at 850 and 500 at 1300. And similarly for OM4, 3500 megahertz at 850 nanometer and 500 megahertz at 1300. Then OM5, we have various options actually, 3500 at 850, 1850 at 953, 500 at 1300. So that's about this minimum overfill modal bandwidth length actually. Okay. So when we talk about the minimum effective modal bandwidth length, OM1 and OM2 is not required actually. But here we have this 2000 megahertz kilometer at 850 nanometer. And this is about 4700 at 850 and here 4700 at 850. Okay, same. So this is about the bandwidth. Okay, right. Uh, and one more thing also I want to, see, we talked, right? Single mode fiber is, supports a single light source. It has a lower attenuation and less dispersion, all this, right? So it can provide an unlimited amount of bandwidth. That's why the specifics are not here. Okay. So this is the preferred choice for high speed interconnection or long distance telecommunication. Okay. However, when we talk about this multi-mode, friends, if multi-mode can transmit in multiple optic modes, as I mentioned here, right? So the here attenuation is high and the dispersion is also large. So this is why bandwidth is limited. Okay. So who is the winner now? Yeah, single mode is the winner in terms of bandwidth. Okay. Then we'll talk about the attenuation. Again, attenuation is nothing but reduction in signal strength as light travels through the fiber. Okay. Got it? Yes. So here multi-mode OM1 3.5 dB per kilometer at 850, then 1.5 dB per kilometer at 1300, and OM2 3.5 same, and yeah, this is also same. OM3, yeah, this is a little bit less, 3 dB per kilometer at 850 and 1.5 dB per kilometer at 1300. And OM4 is 3 dB per kilometer at 850 and 1.5 dB at 1300. Both are same. OM3 and OM4 are same. And here we have a various attenuation, 3 dB per kilometer at 850, and you have a 2.3 dB per kilometer at 953, and 1.5 dB per kilometer at 1300. So this is about the attenuation. Okay, this is nothing but reduction in the signal strength. Then how about the single mode? Single mode is, as I said earlier, this is actually less, right? Lower attenuation, right? Yes. So 0.5 dB per kilometer at 1310 nanometer and 0.5 dB per kilometer at 1500, 550. So clearly this attenuation, typically, single mode has a lower attenuation than multi-mode, which is more vulnerable to attenuation here. This is more vulnerable. Okay, good. That's it about the attenuation. Then we go into the color mode. Okay, color code rather. So different colors allow us to distinguish the cables, right? So there is a, what you call standard actually. We call it as TIA. TIA 598 C defines the color code actually. So TIA is nothing but Telecom Industry Association. Okay, this is TIA 598 C. Okay, so here OM1, OM2, it's in orange, right? Yes. And OM3, OM4, it's like, what is this? How do you see this? This is like a cyan color, right? Yes. Then OM5 is a green. Okay. So that's about this. So OM1, OM2 usually has an orange jacket. Okay. And OM4, OM3 and 4 has an aqua color. They call as aqua color actually. Yeah. Yeah. Then OM5 is of course green. Then single mode, OS1 and 2 is typically yellow jacket. That's about the color code. Okay. Then the distance. See, due to the less attenuation and mode dispersion, single mode provides a much longer transmit distance than the multi-mode. As you can see here, 180 kilometer, 100 Mbps, 180 meter or 1 Gbps, 100 kilometer, 10 Gbps, 80 kilometer 40 Gbps, 80 kilometer 100 Gbps, 80 kilometer at 400 Gbps, and 80 kilometer at 800 Gbps. See the distance, okay? As the distance reduces, you have this speed also increase. Okay, that's it. So that's about this single mode. Then when we talk about the distance of this multi-mode, you see here 200 OM1, OM2 also 200, OM3 200, 550. Anyway, the point is this is a higher distance, longer distance. This is a lesser distance. So that's about friends. No need to go into detail much. Okay. So the point to note here, multimode cabling is only used in short link. That is a point. 550 mm for 1 Gbps, for example, right? Okay. 550, where is that? As you can see here, where is that? 250, yeah, this one, right? 550 mm. Sorry, 550 meter, 1 Gbps, for example. Okay. And of course, it provides a low cost actually. However, single mode is mainly used for a long distance. That is the point we should take note. So now you would have arrived what to use, which type, right? Yes. So now we dive deep into the cost actually, but there is a little bit challenge. I cannot put that in a different, I mean, in the normal way like multi-mode, single mode. So what I did here was like, the cost will segregate into fiber cabling and transceiver and the system upgrade. Okay. So let us go into the fiber cabling cost. Okay. Right. So because of the many advantages of the single mode fiber, right? Many people might think that a single mode is more expensive than multi-mode. However, the opposite is true. Is it strange, right? Yes. So the reason is that single mode fiber is more efficient to manufacture. Yes, saving an average of 20 to 30% compared to multi-mode fiber. There's no doubt. But if you consider more expensive, if we consider the more expensive OM3, 4, 5 fiber, single mode can save about 50% or even more. You got it, friends? So the point is, many of the advantage of single mode, people think that single mode is more expensive than multi-mode. So, but it is not so. Single mode is more efficient to manufacture, saving an average of 20 to 30% compared to the multi-mode fiber. Okay. You got it? So if you consider the more expensive OM 3, 4, 5, single mode can save about 50% or even more. So that is about the cost I want to put forth. Okay. Yes. Maybe I can put this also here. See, single mode SFE, it's about 5.9. Multi-mode, you see, 5.9, of course. And single mode SFE, you have 15. And multi-mode 11. And single mode SFE is 37. And multi-mode 24. And single mode 49. And yeah, this is about 239. But it's all depends on your, this one. Okay. So we need to actually come out with okay, anyway, what I want to do, I will talk about the optical transceiver. That one also we need to discuss. Otherwise, this table will give you a totally a different understanding. I will give that first, then we'll go into that. So, as an essential segment of fiber cabling, optical receive transceiver takes up a large percentage of cost sharing, right? Sometimes, that is about 70% of the total cost. So in most cases, a single mode transceiver is typically cost 1.2 to 6 times more than the multi-mode. And that is why you would have seen the cost is higher. Okay. Because a single mode usually utilizes a higher power laser laser diode, which is more expensive. Meanwhile, the multi-mode devices typically use the lower cost LED, or you call it as a VCSL, right? So that is what we discussed, right? What is that? I need to look back. Yeah, VCSEL, right? VCSEL. So the point is, taking this optical transceiver as an example, we can compare the cost in the table. Okay, this is what actually. So because of this, transceiver, you can see the single mode is looks like yeah, slightly higher because of the transceiver. Okay, so that is the point. I leave it to you. I don't want to discuss much on this. And of course, system upgrade cost. When we talk about the system upgrade cost, the dramatic growth in the the development, the cabling to upgrade and the expand, all these actually, when we talk about this generally single mode fiber cabling provides more scalability, flexibility and elasticity. So due to the limited bandwidth and short distance, multimode fiber will make it more challenging to meet future long distance, of course, isn't it right? So plus, additionally, for the single mode fiber, we could easily upgrade the system by changing only the switch and transceiver. We don't have to, lay new fiber. So that is the point, friends. See, for a single mode fiber, we could easily upgrade the system. How? By changing only the switch and the transceiver. No need to, lay or new fibers actually. But for multi-mode, we must replace the OM2 with OM3, then OM4 for higher speed transmission. You would have seen that in the previous slide, right? Yes. So, however, changing fiber will be much cost actually. It will cost much cost. So to summarize, friends, on this aspect cost, to summarize, forget about everything whatever I have said. Yamabab, multi-mode provides a lower cost for short distance. Single mode fiber best choice for medium to long distance. So that is how you need to look at it. Again, I repeat, multi-mode provides lower cost for short distance. As you can see here, yeah, probably you can see here the multi-mode. Yes, so it's a lower cost for short distance. But the best choice, single mode is the best choice for medium to long distance. Okay, right? Got it, friends? That's it. You may ask, it is costlier. Yes, it is costlier because of the transceiver part. It is costlier because of the transceiver part. Okay. So that's about this costing and application. Yeah, of course, single mode is mainly for, long distance, right? Backbone, and metro system, telecom, datacom system. Multi-mode is mainly for the short distance. Okay. So yeah, like data center, cloud computing, security system, LANs, all these actually local area network. Okay, so that is about this single mode versus fiber. I mean multi-mode fiber optic. Thanks for watching, and don't forget to like or subscribe, friends. Thank you. and see you in the next session, the question and answer session. Thank you. Take care. Bye-bye.